Shri Gurubhyo Namaha, children. Today we are going to continue again with thermal physics. Hope you went through the introduction part of whatever we have discussed in the chapter. Now we started the chapter with the introduction of temperature, which we defined as the degree of hotness of a body. And we also defined temperature to be the property which determines whether a body is in equilibrium with the surroundings. Okay, and we were also discussing about the definition of absolute scale, otherwise called as Kelvin scale temperature. And the SI unit of temperature is nothing but Kelvin. And we discussed some formulas like how uh, temperatures of various uh, degrees can be converted from one to other. Celsius and Kelvin, Fahrenheit and Kelvin, what is the formula also we discussed that day, children. And then we went to what is called as thermal equilibrium. So what is thermal equilibrium? When the two bodies are said to be in thermal equilibrium, if there is no net flow of thermal energy between the systems, then the body is said to be in thermal equilibrium. We discussed examples to explain these concepts, and then we discussed about the characteristics features of heat energy. So the first characteristic feature of heat energy is heat transfers from a system at higher temperature to a system at lower temperature. So this is the first point we discussed. And the second point is the mass of the system. Whenever there is a transfer of heat, the mass of the system remains unchanged. Okay, and the third one is the heat gained by the cold system is equal to the heat lost by the hot system. So this is what we discussed. And we also discussed about other units of heat energy. One is calorie we defined, the other one is kilocalories. Okay, so hope you went through all these definitions. Today we are going to continue with effect of heat energy. So what are the effects? Now when you when the temperature of our today's topic is thermal physics part 2, we are going to talk about expansion of substances. But before we go on to the topic, let us talk about the effect of heat energy. So what happens when you give a certain amount of heat energy to a substance? So definitely there will be some change in the substance. So what is the effect on a substance when heat is given to it? So first thing is, what happens to the temperature? The temperature of the body or the temperature of the substance rises. Now whenever you keep when you want to heat a milk, immediately as soon as you keep it in the stove, immediately what happens to the temperature of the substance which is milk? It starts raising up. So immediately as soon as you give heat energy to a substance, the first thing is the temperature of the substance, it rises. Okay, then the second point is the substance may change its state from solid to liquid or from liquid to gas. So when you heat water, okay, when you keep on increasing the temperature of the water, at a certain stage what happens? All the liquid will be converted, it evaporates. So the substance may change its state. Suppose if the substance is in solid form, now take a ice cube from a freezer and keep it outside. After 10 minutes you would have seen that the solid ice will be converted into liquid. So when the temperature is increasing in a body, the substance may change its states from either it may change from solid to liquid or from liquid to gas. So any changes in the state can be occurred. So this is the second point. Okay, this is the second point on the effect of heat energy, right? The third one is, this is what we are going to learn in detail now. The substance will expand when heated. Now, for example, take a thermometer. Okay, hope all of you have seen a thermometer. Now, what for the thermometer is used to check the temperature of a body, right? Now, what happens? Now, there is a kink inside the thermometer which is filled with mercury. Now, when you keep the temperature inside the body of a person who has got a fever, immediately what happens to the mercury there in the kink? It starts racing. Have you observed that change? It starts racing, which means whenever you have a change in temperature, whenever you have a rise in temperature, the substance inside it, sometimes it may expand due to the heat. So this is what we are going to discuss in this topic. So how the substance expands when it is heated. Okay, so what are the 3 points on which has an effect, heat energy effect? Is the first point is the temperature of the substance rises. Now the substance may change from its state. Either it may state from, it may have a change from solid to liquid or from liquid to gas. And the third point is the substance will expand when heated. Okay, ma. Now this concept is explained in your textbook. Take page number 34, children. What is expansion of substances? Now, when heat energy is supplied to a body, there can be an increase in the dimension of the object. Dimension in the sense the length of the object may change, the area of the object may change, or the volume of the object may change. So the dimension of the body will be changing when energy is supplied. What energy is supplied? When heat energy is supplied to a substance. So this change in dimension is nothing but you call it as thermal expansion. So what is thermal expansion, children? Thermal expansion. Thermal expansion of the object is nothing but change in the dimension. Change in the dimension. Dimensions in the sense they may have a change in the length, they may have a change in the area, they may have a change in the volume. So change in the dimension of a body due to rise in temperature. So when you increase the temperature of a body or when you supply heat energy, what happens? Definitely temperature will rise. So that rise in temperature will change the length, area or volume of any object. So this expansion is called as thermal expansion of the object. Okay. Now, the expansion of liquids can be seen when a thermometer is placed in warm water. This is what I was explaining you. When you keep a thermometer in a warm water, immediately the mercury in the kink of the thermometer will start raising. Now it is due to the rise in temperature of the body, right? All forms of matter undergo expansion on heating. So we are going to go in detail about this expansion of substances. So there are three types of, now we are going to talk about expansion in solids. So this is our first topic, expansion in solids. So there are three types of expansion in solids. The first one is linear expansion. The second one is superficial expansion. And the third one is cubical expansion. So linear expansion is the body, there is a change in the length of the body. Then in that case, you will call that expansion as linear expansion. If there is going to be a change in the area of the solid, then you call it as superficial expansion. And if there is going to be a change in the volume of the body, then you call that expansion as cubical expansion. Okay, so let us move on to linear expansion, or otherwise it is called as longitudinal expansion. Linear or longitudinal. So look at the definition, children. If there is an increase in the length of a solid object due to heating. So when you heat a body, if the length of the body, suppose let us take this, take a pen. Now if this, take a substance, if the substance is given heat energy, if the length of the substance is increasing, then the expansion is called linear or longitudinal expansion. Clear? Look at the definition. Try to understand the definition clearly. If there is an increase in the length of a solid object due to heating, then the expansion is called linear or longitudinal expansion. Okay, right. Now, we are going to have one more term related to this, which is called as coefficient of linear expansion. So what is coefficient? Now when we go in detail about this linear expansion, so how much is the raise in the length of the body? With that, if that is going to be measured, that is measured as coefficient of linear expansion. Look at this definition, children. It is the ratio of increase in length. Increase in length, how much is there, how much is the length is increased, that can be determined. Okay, so it is a ratio of increase in length of the body per degree rise in temperature. When you increase the temperature to 1 degree, what is the increase in length of the body to its original length? It is measured as coefficient of linear expansion, and the SI unit of coefficient of linear expansion is per Kelvin. Now look at this diagram. You will be able to understand this better when you see this diagram. Now look at this diagram. Now here the original length of the body, let us consider. Now here it is a body whose original length is represented as L naught, and at temperature T naught there is no rise in the temperature of the body, so the initial length of the body is considered to be L naught. Now what happens? I'm increasing the temperature in this body, so temperature is increased from T naught to I'm increasing the temperature for a change of del T. So T naught plus some value of temperature, it will have a value. Suppose let us say T naught means 0 degrees Celsius. When I start heating, 0 plus it, the temperature will keep on raising. Okay, so that temperature is given as T. So in that rise in temperature, the length of the body is changing from L naught to L. Look at the length being increased here. So what is the increase in length? The increase in length is given as del L. There is a small increase in length. So this is the increase in length for a small change in temperature, which is called as del T. So this is nothing but you call it as linear expansion. So I will have an equation for this, which is given as del L by L naught equal to alpha L into del T. So what is this del L by L naught? This is what we read as the ratio of increase in length of the body to its unit length. Ratio of increase in length of the body. So this is del L by L naught, and this is proportional to T, and this proportionality I replace by a constant called alpha L. Now this alpha L is nothing but you call it as coefficient of linear expansion. Okay, so this increases ratio of change in the length to the original length when it is proportional to temperature. When you increase the temperature, the length will change. So when you replace this proportionality by a constant, this constant is nothing but you call it as coefficient of linear expansion. So what is del L? Del L is the change in length. So let me write the terms here, children. Del L is change in the length. Okay, change in the length in the sense, if the initial length is 6 centimeter and the final length is 8 centimeter. So what is change in length? It is 8 minus 6, which is 2. So that is change in length. Now what is L naught, children? L naught is nothing but the original length of the body. So change in length, original length, and I have already written alpha L. What is alpha L? Alpha L is nothing but coefficient of linear expansion. And what is del T here? Tell me what is del T, children? Del T is nothing but change in temperature. So when the temperature is changed, how the length is changed? Change in temperature is again final temperature minus initial temperature. So this is about linear expansion. So if the length is changed, then it is defined as linear expansion. When a body is heated or cooled, the length of the body changes due to change in temperature. Then the expansion is said to be linear or longitudinal expansion. Linear expansion is otherwise called as longitudinal expansion, and it is given by the formula del L by L naught equal to alpha L into del T. And the coefficient of linear expansion is per Kelvin. Is it clear, children? Is it clear? Right. Next we are going on to superficial expansion or areal expansion. Now superficial expansion is increase in the area of a solid object. So whenever a body is heated, if the area of the body, there is an increase in the area of the object due to heating, then the expansion is called superficial or areal expansion. Okay, and again when we talk about coefficient of superficial expansion, it is the ratio of increase in area of the body per degree. Per degree means when the temperature is raised to 1 Kelvin, per means 1 per degree rise in temperature to its units area. Again the SI unit is per Kelvin. Look at this diagram. Now here this is a diagram. Now a body whose area is initially A naught. Now when you give heat energy to this body, there will be a slight change in the increase in area of the body, del A. So del A is increase in area. A naught is original area. Okay. So when heat energy is given, the area is changed. So how it is changed? It is given by the ratio of del A by A naught, that is change in area to its unit area, which is proportional to the change in temperature. Now this proportionality is again replaced by a constant which is called as alpha A into del T. Again I will write what is alpha A here. Here again coefficient of this alpha A is nothing but, you call it as coefficient of superficial expansion. So what is this term, children? Coefficient of superficial, superficial, superficial expansion. Okay, and del A is the change in del A is change in area, A naught is the original area, del T is the change in temperature. Okay, so look at the definition, page number 35, children. Superficial expansion: if there is an increase in the area of a solid object due to heating, then the expansion is called superficial or areal expansion. So superficial expansion, otherwise called as areal expansion. And the ratio of, go to the next paragraph, third line, children. The ratio of increase in area of the body per degree rise in temperature to its unit area is called coefficient of superficial expansion. Now the coefficient of superficial expansion is not the same, it is different for different materials, and the unit for coefficient superficial expansion is per Kelvin. Okay, and the equation relating this is given here. So del A by A naught is proportional to del T, alpha into del T. This is the equation. Okay, ma. So where alpha is nothing but, you call it as coefficient of superficial expansion. Okay. Next, cubical expansion. Cubical expansion or expansion or volumetric in the sense when there is a change in the volume of the object, that is called as volumetric, change in volume. Okay, so if there is an increase in the volume of a solid body due to heating, then the expansion is called cubical or volumetric expansion. Okay, so when you heat the body, if the volume of the body is getting changed, then you call it as cubical expansion, and it is also measured as the ratio of increase in volume of the body per degree rise in temperature to its unit volume is called coefficient of cubical expansion. Again, it is measured in per Kelvin. Look at this diagram, cubical expansion. Now here, when a solid, this is a cubical, imagine this to be a cube. This is a cube, and when you heat this object, the dotted line represents the volume of the increased volume of the cube. You have a dotted line, you have dotted lines here. So when the temperature of this body is increased, the volume of the cube increases. Okay, this is the change in the volume that is represented as dotted lines. So change in volume to the original volume is nothing but cubical expansion. So it is also given by del V by V naught proportional to del T, or del V by V naught. This proportionality, when it is replaced by a constant, it is replaced as alpha into V del T. So again, what is alpha V? Alpha V is nothing but, you call it as coefficient of cubical expansion. Coefficient of cubical expansion, and again it is measured as per Kelvin. So three changes we have seen. The first one is linear expansion or longitudinal expansion, which means if you heat a body, if there is an increase in the length of a body, then you call the expansion as linear expansion or longitudinal expansion. The second, and the coefficient of linear expansion is nothing but the ratio of increase in length of the body per degree rise in temperature to its original length, and its unit is measured as per Kelvin, and the formula relating the topic is del L by L naught is equal to alpha L into T, where del L is the change in length, L naught is the original length, and del T is the change in temperature. Then we'll go to the next topic, which is called as superficial expansion or areal expansion. Again, here it talks about increase in area of a solid object due to heating. Then the expansion is called as superficial expansion. Again, it is a ratio of increase in area of the body per degree rise in temperature to its unit area. And the SI unit is per Kelvin. Then the third one is cubical expansion or volumetric expansion. If there is going to be an increase in the volume of a solid body due to heating, then the expansion is called as cubical expansion, and the coefficient of cubical expansion is nothing but the ratio of increase in volume of the body per degree rise in temperature to its unit volume. Okay, so these are some of the formulas, and in your textbook page number 35, there is a tabular column, children, which talks about coefficient of cubical expansion of different materials. So they have given four materials. One is aluminium, the second one is brass, the third one is glass, fourth one water, and fifth one mercury. So what is the coefficient of cubical expansion of these materials? It is discussed in the tabular column. Just go through the values once, maybe it is asked in 1 marks. So remember the values of these materials. Okay, ma? So go through the topic, whatever we have discussed. Tomorrow we'll be discussing expansion in liquids and gases. Okay, ma?